All right, this is part 3 of the lectures about the features of Cisco. And well, we'll get started. We're going to talk about layer 3 routing or switch routing, and we're going to talk about NTP. And whatever else the slides tell me, there's a little nagging voice in the back of my head telling me there's something else, but there might not be. All right, so here's the website. These are the slides we'll be doing, big time punctuality. I hope someone enjoyed my little York egg. What do you call it there? I want to say eggplant. What do you call it there?
Easter egg.
Easter egg. Thank you. Yeah. All right. So we talked about DHCP. We talked about sub interfaces. We talked about just recently. We talked about setting up NAT, which is quite a complicated subject. And hopefully when you do it in the lab, it'll make more sense. You'll also get a chance to do it in the project too, I assure you. So right now we're going to talk about layer 3 routing, routing on a switch. All right. So the first thing you need to do is you need to tell the switch it's a router. Okay, a switch is not a router. The only thing you need now before you turn on this command, this IP routing command, it does nothing else but switch. It is a switch. The only thing it needs an IP address for is to talk to be telnetted into or SSH'd into. If it has a web page built into it to view the web page, a lot of the newer switches and routers have web pages. Yeah, I didn't really go too deep of that in any of the lectures. Cisco, starting in 2000, I'd say 2002, 2003, started having web pages on the side, right? Their devices could be web servers too, right? So they just put a little web server in there. And most people kept them off, most of the pros, and made fun of them, and they were awful. They've gotten better and better over time, but there's this now, again, the problem with a slow rollout or a incremental rollout sometimes, especially if you're in something in a very nerdy engineering world like Cisco, is that rollout was so slow and so painful. Well, the earlier models were so feature less, not rich, but less, so poor, feature poor, that essentially now that all the text just, only newbies use the GUI, even though the GUI's gotten better. But I still hated the GUI when I did it, because when I could tell when people were using the GUI, because they'd add all these extra commands. I'm like, no one types that in. Someone ran the GUI. I can tell, right? Anyway, so that's one reason why the switch would need an IP address if you don't turn on routing. Okay, so until you use this IP routing command, you do not need an IP on a switch for it to function as a switch. However, once you hit this IP routing in global config mode, IP routing will then be enabled. This is, okay, cool, I'm a router. Okay, it still can't route because it doesn't have IP addresses just yet. Okay, so now you can edit and add static routes. So just like a normal router, you could put, after you do IP routing, you could do the IP route command. Okay, see, it's different right here where there's I and an E, so there'll be a difference. You type IP route. Here's a static, that's this gateway of last resort, static quad 0, or a default route, whatever you want to call it. In this case, we're saying, hey, send all traffic to 134.241.1.1. Okay, just like we would before. You can actually have routing protocols run on there. It's going to eat up a little bit of the horsepower of the switch. Again, switches and routers operate very differently. The processors on the switch, tend to be less powerful than a router because a router does more thinking. Again, it depends on your model. It depends on what you're doing. Remember, switches, in order to be fast, rely on ASICs, integrated circuits, right? They rely on moving those packets from board to board. So it's all about kind of connectivity on the motherboard, as compared to routers who rely more on RAM and processing power, because essentially they're doing a lot of thinking. So running a very complex or very large routing protocols on a switch is probably not ideal. Okay, so just to let you know, so they're, well, we have a switch, well, we might as well have that be a router. I doubt a lot of ISPs use switches as their backbone router because of that. They're not built for it. It can do it, especially these Cisco devices that are costing $10,000. They tend to be overbuilt. They tend to have processors that are have a whole lot of horsepower, a whole lot of muscle, so they can get away with it. But whoops, I hit a button. Went back. Anyway, so you can run routing protocols as well. You type no switch port. So yeah, once you do that, you have to go into an interface, right? Again, at the end of the day, a router is going to take, what's the job of a router? You turn the switch into a router. It's still also a switch. It can do both jobs at the same time. Again, eating up a lot of, again, you don't need a lot of process power to be a switch if you have integrated circuits. So anyway, it can do both jobs at once. What you need to do is go into the interface and tell the interface, though, that it's no longer a switch port. It will not participate as a switch port. It changes the whole mode of that port. It changes everything on that port, right? That port no longer functions at layer 2. It functions at layer 3. Okay, so this command is critical, right? There's a lot of critical commands here that if you forget, you're done, right? IP routing. Before you do IP routing, you can't do any of this. Before you do no switch port, you can't add an IP address to an interface, which you're going to have to do. So remember, a router needs interfaces. That's our job of a router, is to take a packet off one interface and put it on a different interface. As we've seen, we complicated it. We could do sub interfaces. We can do anyway. So, but that's the purpose of a router, is to move a packet from one interface to another interface. All right. So the moment I do no switch port, then IP address. I can now add IP address. In this case, I gave it a 134.241.1.2. Apparently, it's on the same subnet as this. So now it can route between these two ports, right? You can also set up a switch like a router on a stick, although you do it a different way. Remember, switches had interfaces per VLAN. Remember interface VLAN 1, interface VLAN 2. Well, here you go. This is stupid menu thing on the bottom. One day I figure out how to not point down below. So it's like touching the face. I shouldn't be touching the face, but anyway, I can't help myself. IP address. So what we're doing on this bottom command, I'm pointing at it, which is useless to you. VLAN 2 IP address 10.162.162.9. We're giving that a subnet mask of 248. Anyway, so the point is, that's if I have a trunk port, okay? So if I have a switch port, trunk port, okay? So I have a interface that's been set up to be a trunk port going to another switch or something along those lines, okay? The point is, I'm able to handle VLAN 2 traffic. I can put an IP address on that. Let me bring up the whiteboard and do a little bit of drawing. Oh, I can note too. I can actually draw on things. Look at that. Ooh, all right, that's fun. All right, let me stop that and note. And all right, clear it, stop it. And sorry to be playing as we go, but I thought I could share a desktop. I'm gonna stop the share, bring it back to me, and then I'm gonna bring up the whiteboard. Here it is, share. All right, so let's get a situation where we have a switch, right? So this is where we're talking about setting up a switch as like a router on a stick scenario, okay? But we're gonna run layer 3. There's a layer 3 switch, okay? Just like that scenario I just set up there. I'm gonna remember the IP addresses off the top of my head, but I'll come close. We have a router, right? This is gonna be an access port. Again, you can, go create, it's gonna be on some VLAN, but this is an access port. So it's only gonna carry one VLAN's data, and that's that 134.241. I'm trying to remember the IP. I think it was 1.1. All right, and then remember, I set up that interface, whatever interface I went into there, 134.241. I have an interface there, 1.2. If I remember correctly, it was a /30. All right, and that's a /30 out as well. So now I have my default route out of here. This is almost like a stub network, okay? Now, if I want to set this up as a router, as a stick, I would then go to a layer 2 switch, right? By the way, I could have workstations off of here too. I mean, I don't need to go to a layer 2 switch, actually. If I have workstations out here on different VLANs, say I have VLAN 2 through 4 that I want to set up routing for, I would have all these on different VLANs. That'd be VLAN 2, this would be VLAN 3, this would be VLAN 4, right? Let's just say this is VLAN 1, so I don't want to put anything on VLAN 1. I'll make this VLAN 2 as well. All right. And what I do is I go to those interface VLAN. So if I go into global config mode, int VLAN 2, then what I can do is give it an IP address. So when these workstations say, hey, I need my default gateway, it can hit the switch's IP address on the VLAN, which would have a MAC address, and it'd be treated just like a default router. Okay. If I want to extend that out to another switch, which then has VLAN 2, VLAN 3, VLAN 4 traffic out here, right? I would make this a trunk port with the VLANs that I service running over that trunk port, right? As long as this switch can then talk to those IP addresses, which it'll be able to do over layer 2, right? It'd be able to get to that MAC address that's been assigned to that IP address. Then I can do routing between all these devices. So if this guy VLAN 2 wanted to ping this guy over here who's on VLAN 3, it would hit the default gateway through this trunk over here. This is what makes it kind of like a router on a stick situation to hit VLAN 1. This is a very complicated thing. I'm not going to have you do that in the practice. I do want to make a tough project for you here because we're a little light in subject matter, and to keep the two courses somewhat in line, I want to give you a somewhat tough project so you can spend some time on. But I also need to be cognizant that you guys are a lot of you are getting ready for your Internet Security 3 project as well. So anyway, any questions before I move on to NTP? Again, this is something we're going to do in the lab. I'll go back. Let me share that real quick. Back to me. Hello. And then let me bring up the lab here. This one right here, this switch right here, as you can see, it has IP addresses on the interface. I didn't set up a router on a stick situation with this switch because I thought that would be complicated. So what I did was I gave it an IP address of 192. I just had single IP addresses. What this switch is going to do is route between this subnet, and then set it back to this guy, which is the only way out to get to the internet. So this is kind of like a stub network. So you can just do a simple default route going out to 192.168.0.1. All right. So that's what we're going to be doing in practice. I'm not going to have you do a router on a stick. Now I'm kind of talking myself into it as on the project. So if anyone wants to stop me, speak now. So in other words, I haven't done the project yet, but I'm going to see where people are struggling on the practices, and that may cause me to put it in the practice or in the project, or it may not. So I don't want to make it too difficult as well. So, but that's what we're going to be doing in the practice. We're going to just set up a simple switch here that's going to route between these two subnets. That's why we have stupid layer 2 switches, because these are routers, right? So this switch right here, I could, by the way, I could have a workstation. Let's put another workstation up. I was using WebTerm as the workstations and changing the icons. So I could put another workstation in here and connect it up from here to a interface that I have set up as a simple switch interface, and this would operate as both a switch for this web turn on whatever VLAN I put it on for these two device, these two networks. I could have it be both a router and a switch at the same time. So it could act like a switch for these devices, and then for these devices, that switch is a router, right? Does that make any kind of sense at all? Let me start up the router real quick. I gotta click this off. I'm gonna right click on this, hit start. Or I'm sorry, the switch that's acting as a router. I meant to play with putty. Yeah, John, go ahead.
Okay, is that based off of how you configure each and every port?
When you say is that based, do you mean is the fact the switch is a router based on that, or?
Like for example, the fact that you added a workstation, but yet that's working in layer 2, correct?
Yeah, that's working in layer 2. It's based off how that port is configured. Okay.
Okay.
So
Yeah,
right now the switch is completely unconfigured. So if I went and if I sit there and say, hey, I want to put an IP route in this, for example, and make a default route. So we'll do quad zeros. And I'm going to do 192.168.0.1. I should get an error. Yeah, well, it says incomplete command, hopefully. All right, unrecognized command. There you go. I get an error. I can't put this command in, even though I'm pretty sure I got it right. Oh, do I need a subnet mask? No. It's acting weird. So It says,
Like, for example, in the last slide you showed us, you
yeah.
put a command that said no switch port. Now, when you put that command, that's actually is that telling the switch to become a router, or is that only based on using that command for certain ports?
It's telling, so there's two big commands here. The first one is IP router, or routing, excuse me, IP routing, okay? That turns the switch into a router. That command right there, IP routing, this switch now says, uh-oh, I'm a router too. It doesn't turn it completely into a router. The switch says, okay, I'm doing both jobs. I am both now a switch when the interface is set up to be a switch, and a router when the interface is set up to be a router, okay? Oh, you're not seeing this. I'm sorry. I forgot. I have to share that out. Sorry. Let me bring up Putty. Hey, Christian. So let me share out the Putty. Sorry about that. I forgot. So I just turned it on with doing IP routing. Okay. I turned in IP routing. Now that router is, or that switch says, okay, I'm also doing routing. Now, if I do a do show run,
Okay.
you're going to see the interfaces are still unconfigured. So all these right now, all these interfaces on this switch are all switch ports, all operating on VLAN 1 because they have the default configuration. Okay. Let me put in IP route. Let me put the quad zeros in. 192.168.0.1. There I go. Now it's happy with that command. Before I ran the exact same command and it wasn't happy. That's because I'm not a router. It didn't give me a good error message because welcome to Cisco. Cisco's like, hey, you're supposed to be smart enough to figure this out yourself. Now what I would do is let's like go to Ethernet port 1. If I go int Ethernet 1.1, right? And now I say no switch port. Okay.
All right.
Now when I do no switch port, it says, uh-oh, I'm not a switch anymore. Now I can do IP address, and I'm going to add 192.168.1.1, and that's /24, nice and simple. The butter side up folks are simple. The butter side down folks are not. So there you go. I took the IP address, and I'll put a description. Default gateway, I'll just put DG for this VLAN, whatever. I'd have to give it an IP. I'd have to give it a VLAN if I wanted to make it. I'll have to give it a VLAN, but to make it make sense for me, I'd give it a VLAN. I'd give it a VLAN 2, right? All right. Now, if I go into the other, let's go into real quick. I want to go into interface Ethernet 2.2. So if I go interface 2.2, which is, if you look back, on the lab, that's the other interface that goes out to the switch. I go to interface 2.2. Watch what happens when I try to put an IP address in. I say, oh, IP address. Oh, well, first of all, right off the bat, it won't let me tab it out because they're like, you're an idiot. No, you can't do that, right? You can't do IP, right? It stopped me because I could do an access grouping, which we'll talk about later. But it won't let me do IP address until I type no switch port. Once I do no switch port, now, yeah, sure, IP address, go ahead. Just tell me what IP address you want, right? That's so 168.2.1, and that's 255.255.255.0. So there you go. And now if I went into Ethernet 0.2, the one I hooked up to the web term I just put in, I put that switch port access VLAN 2. So now I'm telling it, yes, you are a switch port. You're gonna be an access port, and you're servicing VLAN 2. I didn't have it yet. We didn't set up the VLANs because you'll do that in the lab in the practice. But anyway, so this port E02 is now a and let me switch back to new share. Not the stop. I thought I could change out. Pause share. Let me go back to this screen. There we go. You should now see the drawing now. So you have an IP address here. That's why I just configured. I configured this IP address, and this port E02 would then also magically now suddenly be a normal switch port. So again, a switch that's been set up as a router can both be a switch and a router simultaneously.
That's awesome. So we can set up VLANs on these layer 3 switches apart from using the router itself then?
Yep. And if you set up VLANs and put IP addresses on the VLANs, you could also set up, that's an advanced configuration, but you can also set up the switches as almost being like a router on a stick. Yeah.
Okay. Awesome.
Yeah. In this case, we had extra switches, so we plugged them in that way. I could also set this up to be a router on a stick situation where I assigned IP addresses to the VLANs and then had all these as access ports and had the workstations connect them directly. Again, you're eating up processor power when you do that. Every time you add in a little feature, so in this case, this would be kind of routing on a stick feature, you eat up a little bit of more processor. I don't know, in a way, making these interfaces, I don't know if that's more or less processor. But the point is, switches, you're really doing round peg or square peg round hole here. So it's not, a switch isn't 100% built to do this, but this is available if, you know, especially if in this case we have 2 workstations, but I'm sure there's more. If you have like 20 or 30 workstations, it'd be fine handling this, right? It's when you get into a massive, in the middle of a big corporation, it's not ideal. And a Cisco, a CCIE would walk in and go, "What the hell are you doing?" Right? You know, no wonder your traffic's slow. No wonder you haven't dropped packets, you idiot, right? So, so keep that in mind as well. All right. Any other questions on that? Hopefully, when you do it in the practice, you'll have an aha moment. For me, when I learned the Cisco stuff, until I hit enter and all of a sudden my ping started working, I didn't really understand it until I did that. So I do have that assumption that doing that for you would have the same effect. That when like I said, one of my favorite things in the world, I mean, this is back in the day before virtual machines, I would literally have a workstation to my left, which I currently have. I have 2 laptops on my desk right here. I would have a workstation on my left having a consistent ping failing, and then I'd hit the enter button at whatever command I was putting in, be it a NAT or be it setting up routing or whatever. And all of a sudden I hit enter or an access list, and all of a sudden magically started working. I would go, that's how it works, right? And I'm hoping that kind of happens for you with some of these practices. So. All right, I'm going to switch to the back to the slides, and then we're going to finish.
Question.
Oh, sure, go ahead.
Sorry. So that switch in that example, would that need to, anytime that a switch is used in that manner, would it need to, it'd have to store its own routing table?
Yes, it would have its own routing table. Absolutely. Let me, matter of fact, I can bring that. I'll bring up the putty. And because we've created those interfaces, if I do now, all of a sudden magically, because I did that IP routing command, I now all of a sudden have this command too, show IP route. It didn't, and you can see right here is its routing table. It says I didn't set the gateway last resort. That's fascinating. I thought I put that in. Maybe I didn't. Anyway, so here we are with two networks that it says. I have 1.0 and I have 2.0, right? And it knows that based off the way I set up those interfaces.
So yesterday, one of the examples, I think one of the things we went over was talking about a trunk port off a switch to a router. If there's multiple VLANs on the switch, the traffic has to go through the switch over to the router, which then essentially routes it back to the switch.
Right.
Get the direction to go. So in this case, the switch would take over that role and almost...
yeah, I mean, you wouldn't have it. You wouldn't have it both ways. You wouldn't do a router on a stick and a switch on a router on a stick situation. Right. Now you have multiple routers. Unless you want to do it as a backup, you could. I mean, in theory, if the main router goes down, some idiot unplugs it or spills a drink on it. Now the switch can take over the job. We'll talk about hot swappable routing protocols, which is the old term. I'm showing my age actually. There's newer terms, but you could set it up where you actually have two routers on the same network, and if one router goes down, the other router can take its job over. So you could set up the switch to do that, but yeah, it depends on if you have a router. This is primarily in a situation where you don't have a router. You sat there and said, I can either buy a really nice switch or I can buy a really nice router. Right, and the routers tend to be a little bit cheaper, by the way. So I'm like, I can buy a really nice switch or I can buy a router. I'll buy a switch because the switch can also be a router. And it's like a small little, office of like 20 people, right? And then the switch can handle and do both jobs for you. That's really what they're thinking of when they come up with this, right? Is, instead of buying a $5,000 device and a cheapo switch or 3 cheapo switches, why don't you just buy one of our really cool switches? And really Cisco's become more of a switch company. Where they want to sell switches. Again, remember the core of their network is the switch, right? The switch is what makes things fast. To the modern thinking of, well, I wouldn't say to All right, now we're in postmodern, I suppose. So postmodern, which is where we are now, is everything's cloud-based. But at the core of the network, when you get into the middle, what they're saying is, hey, we want this as fast as possible, and the best way to do that is a switch. So, but then they'd be a little weary about all these the routing you're doing on here, because you're like, well, you're kind of eating up some processor here. Why are you doing this? So again, but at the access layer, they'd be like, yeah, sure, use a switch as a router. That's fine. You're supposed to slow things down at the access layer, right? Or at the distribution layer. But anyway, yeah. I hope I answered your question. I certainly went on long enough, but did I answer your question, Adam?
Yeah, you did.
All
Thank you.
All right, good. All right. So that's routers as a switch. Again, hopefully when you do it in the practice, it'll make a little bit more sense. I know right now it's very theoretical. It's in the brain, so it's not. Hopefully when you touch it and hit the enter key, it makes more sense. We have one more thing to go over. Oh, I guess summary was the thing I was thinking of. One more thing to do, which is NTP. Real simple. Okay, network time protocol. It's port 123. All it does is it points to an NTP server. NTP is like this giant game of I forgot what they person telephone, whatever politically correct way I believe it. Back in my day we said it unpolitically correct, and it's not a good thing. But whatever, human telephone or whatever, where everyone kind of just passes the time around. There are I don't know, I can off the top of my head 5 or 6 nuclear clocks. I know Berkeley has one, MIT has one. There's one out in California or Colorado, New Mexico, Los Alamos has one. Anyway, there's a bunch of these nuclear clocks. What they do, they measure the decay of the nuclear decay of molecules or of atoms, and that's the most precise way to measure time. Okay, and they give out the most precise way scientists have of measuring time, which again is all abstract and a construct, but whatever. Point is, these servers give out the proper time. The time now is, right? That's what they do. It's a simple protocol that just simply sends out the time. Hey, this is the time. Hey, this is the time. Hey, this is the time. So I can do 2 things on my Cisco devices. I can when I turn it on, okay, I am both receiving and sending NTP status. So I can have one device that has internet access, right? So let's go back to our lab here. Here we go. I only have this router right now that has direct access to the internet, okay? What I could do is have NTP point to the Berkeley clock or MIT clock, whatever my, collegiate alliances lie, Colorado, wherever. I could point it to an NTP server, right? And that NTP server would come back and just keep telling this router the time. Then I could point my switches, if I want to keep it all locally and not go out to the internet, I could have these switches. I could use the NTP command to point them to the router, and the router would tell them the time, okay? So it's almost like a relay, okay? When I say you're both sending and receiving, I'm not saying you're in an NTP server 100%. You're not, you're not measuring the decay of an atom, but what you're doing, not you, Adam, but an atom. When you measuring the decay, or what happens is you receive the information and then you send it out if you're asked, okay? You're participating part of this giant chain of information, okay? It's quite simple to do. You just go into the config, you type, I didn't do it in the practice because we did enough in the practice. We had, I can't remember how many steps, but it's quite a few steps. NTP server, in this case, I gave it a private address, which is weird. Usually it's a public address, or in this case, I might be pointing at a switch or a router. And then to confirm it, I can do show NTP status. That command will actually say that, hey, I'm good. I'm actually an NTP server. If I boot this device up, start, I think I have internet on this. Let me bring up PuTTY, the new PuTTY. I'll close this PuTTY out. It gave me an error message. Why? Okay, yeah, yes, I'm sure I want to close that session. Let me start this session, and then I'm going to switch over to the share of that. Here I am, the PuTTY. All right, that's my router coming up. If I remember correctly, we set it up so we have internet. We do. I got to remember an NTP server though. Anyway, what if I let me real quick get an NTP server. I have to negotiate around the window here. All right. And I'm going to do NTP, NTP server list. Here we go. Let's do, we're in Massachusetts. Although I think we're finding out that we're, all right. So here's a giant list, by the way, of like seriously 15, 16. I'm in Colorado because that's where the nuclear laboratories are. There we go. Here's a government one. It's in Fort Collins. All right, we'll do this one. 192.129.6.15.2. So if I go and I do config t, ntp server, and then I just do Control-Shift-V, Control V. Oh, I'm in PuTTY. Right click. Fantastic. There I am. I hit NTP, and then I go exit, show IP, show NTP status. There we go. We haven't synchronized up yet. It's still. It'll send it out eventually. I can change all that, of course, because this is Cisco. I can go and change the NTP. I can send how often I send it. I can have an access group who's allowed to hit my NTP. All that. So I can set up trusted keys. There's all kinds of ways to do it. It tends not to be a big deal, really, at the end of the day. But you can set all kinds of authentication up and stuff like that. Clock period, length of the clock, hardware tick. All right. I mean, that should be enough time for me to see status. It's still unsynchronized. Maybe it can't get out there. I don't know. Or maybe that IP doesn't exist anymore. Let's try it. Yeah, that's not good. I can't ping it, so never mind. I know I got internet. Anyway, so let's try this one. Maybe the plague took it out. Oh, that one's not working. All right, maybe I don't have as much internet as I thought I did. Or they might be blocking ping. Who knows? They have a IPv6 version on here. Anyway, so that's how it works. I do show NTP status to show me if I'm synchronized or not, what server I'm currently configured to do. All right, I think I've talked long enough. Any questions before I stop recording the lecture? But then I'm going to stick around and we'll work on practices for the rest of the time we got, which is 20 minutes.
Hey, could you use a web address, like a DNS address?
Yes.
For a switch, because I know there's some Microsoft like NIST about Microsoft something.
So a DNS address to do what? I'm sorry, for in what way?
For the network time, like
for NTP, yes.
Microsoft.com or something, yeah.
Yes, you can. I was just trying to be more literal, but let me. I can do that right now. Here's a website. Actually, right now I wouldn't be able to because my router doesn't have a DNS server configured in it. But I could configure you guys have been looking at PuTTY this whole time. Fingers aren't working. Config DNS. IP. Stupid DNS. Nameless, no. I want DNS server. You said DNS name server. IP name server. My brain's not working right now, but yeah, name server. That's it. So I'll give it 1.1.1.1, and if I do NTP server, and I give it a right click URL, it's going to translate it. And again, the internet's not working 100% right now for with this NAT thing going on. But that, as you can see, it's starting to trying to translate it. So it actually would work if you do have a name server set up and you have proper internet. Yeah. Any other questions? All right. I'm going to stop the recording and I'm going to hold on, and we're going to work on if anyone has any questions about the actual practice, which is very possible because it's a complicated practice. So let me stop the recording. I'll stop the share, I suppose, is what I need to do first. Okay, this has been the lecture, and goodbye, everybody, except for the folks that are staying here.